Hi, folks. I hope you're all keeping well. My name's Kieran Nolan. I'm absolutely delighted to be able to present my research for you today for SIGGRAPH 2021. And the project I'm going to chat to you about is called VR SuperGun. And it's a way of interfacing 1980s arcade hardware with online virtual reality. So, a little bit about myself. I'm a lecturer in creative media at Dundalk Institute of Technology in Ireland since 2007, and I'm co-director of DKIT's Creative Arts Research Centre. My research areas of interest include extended reality, interface design, game design, and digital art. And I hold a PhD in computer science, specialising in game studies and media art from Trinity College Dublin, an MA in Interactive Media from the University of Limerick, and a Bachelor of Design Hons in Digital Media from Letterkenny Institute of Technology. So, a table of contents to take us through this presentation. I'll start off with an introduction to what the idea and concept is behind this project. That'll be followed by the design considerations that were taken into mind when putting together this prototype. That'll be followed by a walkthrough of the hardware toolchain of VR SuperGun. And then I'll take you through the software side of VR SuperGun and also a demo of the virtual reality environment itself. And then I'll wrap things up with a discussion about VR SuperGun and some considerations about where the prototype can go next. So, VR SuperGun, well, it's a custom hardware and software prototype, and it allows play of original arcade platforms over a network connection in virtual reality space, and it rebuilds or reconstitutes the material form of the arcade cabinet. So if we look at this picture on the left, this is of a few disused arcade machines in an old shed. And as far as game preservation goes, arcade platforms are particularly challenging just because of their physicality and the materials they're made out of. Quite often, you might see an old arcade machine in a museum, but it'll be out of bounds because it's too delicate to play. So, VR Supergun is a way of accessing the inside of the machine while not physically touching the outside of the machine. So, the outside of the machine is remade in VR space while allowing live play of the actual physical, tangible arcade platform. And some arcade games can't be emulated, so it offers a solution in that way as well. Because of the analog chips that are used as part of them, it's not really possible to totally recreate them as they were. But of course, very, very, very close approximations can be made. Now, the what is a supergun itself? I've been using that word quite a lot. Well, superguns have been around for quite a while, and what they are devices that take the wiring of an arcade machine and compact it into a form kind of like a games console, so that they can be plugged into a TV set or monitor, and the arcade game printed circuit board is plugged into the supergun, kind of like the way you would plug a games cartridge into a video games console. So VR Supergun, it augments the regular Supergun into virtual reality space. When I was putting together this prototype, there were a few different parameters I had to bear in mind. First of all was because I want to be able to play the game live over a network connection, I need to have as low latency as possible. So not just in terms of the controller, but also with regard to the video stream that's transmitted from the board. So I had to go through a few different solutions before I found the one that actually worked without a speed lag that would have rendered the games unplayable. And I wanted this to be a project that was portable, it was easy to duplicate, and could be shared. So it was designed to use minimal hardware resources. And also, it's a game, or rather, it's a game project that's based around hardware of the 80s and 90s. So I just wanted to keep it in that kind of spirit, that I was using similar um, aesthetic constraints in the front end for this design that were used by game designers in the 1980s and 1990s. So that visual aesthetic, it's based on the kind of 3D you would have seen in the arcades at that time. Say, for example, the Virtua Fighter game series by Sega. So this kind of hard polygon style. And that's sort of practical reasons as well. So because this game is made in WebVR, I needed to use a 3D style that wouldn't be too taxing on processor and memory resources for the browser and the hardware it is built on, and also suited my own level of 3D. So it worked in both of those regards. And the project, it's networked enabled, so that's why it was made in WebVR as well. It was a natural because WebVR by its very nature is online. And also, this project used open source and free software where possible, again to help ensure that the project could be duplicated at low cost if needed. So now I'm going to take you through the hardware toolchain of VR SuperGun. And the first aspect I'll introduce is the actual game board itself. So VR SuperGun, like any SuperGun, uses JAMA compatible game boards. So the JAMA standard was introduced by the Japan Amusement Machine Manufacturers Association in 1985, and it was a standard 56-pin connection that supplies power and control inputs to the arcade board and allows it to connect up to monitor and speakers. And this standard was brought in so that games could be swapped between arcade machines from different manufacturers who used this special machine to machine interface. And it helped save costs for the arcade industry and for arcade operators. The next part of the tool chain is the supergun itself. So this is a supergun by Arcade Forge in Germany called the Max Strike. And as mentioned, it supplies those essential inputs and outputs to the game board, but there's no actual computational element to it. All of that work is done on the PCB itself. And the signal, the SCART audio and video from the game board goes through that cable into this box here. So this is an OSSC brand video upscaler, and what it does is it takes this analog signal and converts it into HDMI. And that HDMI signal is then taken by the video capture unit, and it's encoded and sent through the USB cable to our PC. And for this build, I'm using the mini PC called the Latte Panda Alpha. It's a great project machine, and it actually has the Arduino pins built into it for inputs and outputs for physical computing projects. But for this project, for the moment, I'm using a separate Arduino Mega compatible board by Elegoo that you can see on top of those units to the left there. So that's how the video gets to the PC, but then the PC has to control the board also from the browser. So as I mentioned, we have the Arduino Mega there, and it's what the sends the key presses from the browser to the game board. So those key presses, they go through this opto-isolator circuit. So the opto-isolators are electronic switches, and they're connected up to each of the inputs on the JAMA board, but it's a pass-through connector there, so it's in the middle of the SuperGun and the game board. So each of the inputs can be triggered on the board from the PC and from the VR experience that's experience through the browser. So those are the two halves of the connection from the arcade board to the PC. So what we have there is that the host PC can control the game on the remote arcade board, and also the arcade board can send an AV signal to the host PC, which is running the VR experience and allowing a local or remote connection to the game through the VR environment. So next I'm going to take you through the software tool chain and also demo the virtual environment of VR SuperGun. And what you see here is a desktop from the admin point of view. The actual end user will just have what's in the browser on the right. But from the admin point of view, there are a few different processes going on here that are shown in these different command line windows. So the first of these, and they're all executed by a batch file at the beginning in this order. The first of these is the FFmpeg streaming server. So FFmpeg is the brilliant Swiss Army knife of media encoding, and it's what takes the signal from the um, encoder box and converts it into a stream of JPEG images that are displayed as a canvas texture in the web VR environment. And so, first of all, in order to get that stream running, we need a server for it to happen on. And then the next terminal window, it shows us the frames from the encoded video transferring across the server. The next thing that we need is actually the localhost web server itself to host our A-frame web VR environment. So when we have that going, then we're good to go, and we can run what you see in the right-hand window. This next terminal window shows our inputs live as they are inputted into the keyboard and go to the Arduino microcontroller and then go to the JAMA board. So this is just visual confirmation aside of what's going on the screen that we indeed have our inputs working. And then the next terminal window, at present this prototype just uses keyboard inputs, so I'm using anti-micro, which maps a USB joystick to the keyboard controls and allows play of it through a more authentic arcade manual interface. And then we use ngrok to create a tunnel between our localhost server and the remote web. So what that means is that somebody from a remote location can access the localhost web server that VR Supergun's running on and play the connected JAMA arcade game from wherever they're located through the internet. So here's what VR Supergun looks like in the Firefox Reality browser on the Oculus Quest. And the great thing about A-Frame and WebXR in general is that it's platform agnostic. It'll run in any compatible headset that's using a WebXR browser, but you can also experience it through any desktop or mobile platform as flat 3D on a regular monitor, and it's scalable and future proof. So, in conclusion, VR Supergun is a prototype that brings the 1985 JAMA arcade hardware standard into networked virtual space. And it's a technical solution that delivers a trade off between the immediacy and accessibility of game emulation and the tangible and admittedly subjective authenticity of experiencing arcade gaming through the original arcade hardware. And it offers a way to experience arcade games that otherwise would be kept behind boundaries in a museum type situation because of their rarity and fragility and makes them accessible. And it also offers a method for digital preservation of classic arcade and computing hardware by hybridizing the physical computational aspect with software simulation. So, as mentioned earlier, in a museum situation, this could be used to allow play access to arcade machines that otherwise would be off limits to visitors. Also, as mentioned earlier, some arcade hardware can't be 100% emulated. So, this would be a way of allowing access to games in private collections or rare games remotely. So it's a telepresence solution for arcade games and for video game play. So, for example, a game could be shared from one museum or from one collection to another. So, the next steps for VR Supergun are to move from the prototype form that you see here into a more accessible kit form with a reduced hardware footprint and cost so that anybody who's interested in testing out the project can do so. And yeah, it's a continuous work in progress. So anybody who's interested in finding out more, you're always very welcome to give me a shout about it. And thanks so much for checking out my work. And if you have any questions here at SIGGRAPH, please feel free to give me a shout. But you can also get in contact with me online and you can check out more about the project at the website link shown on screen. So, again, thanks so much and enjoy the rest of the conference.